Welcome back, class. Today we're solving quadratic equations by taking square roots. So to use this method, you need to make sure that the equation is either in vertex form, which is y is equal to a times x minus h squared plus k, or standard form, but all you need is a and c. So ax squared plus c. Notice how there's no bx. So if the equation is in vertex form or standard form without the bx, then you can definitely use this method. We have 4x squared minus 5 equals 2. Notice how this equation does not have a bx. So that said, let's go ahead and solve the equation. Add 5 to both sides, and that's 4x squared is equal to 2 plus 5 is 7. We want to isolate x, so let's go ahead and divide 4 to both sides. That's going to give us x squared is equal to 7 over 4. To get rid of the square, we need to take the square root of both sides. And after taking the square root of both sides, we get x equals plus or minus the square root of 7 over the square root of 4. And class, we can't take the square root of 7, so we'll go ahead and leave the square root of 7 as is. The square root of 4, however, that's just 2. And that's our answer. So x equals plus or minus square root of 7 over 2. Now let's look at problem B. Notice how we don't have a bx. So for this problem, we're going to use the square roots method. And so we're just going to solve for x directly by adding 8 to both sides. And that's going to give us 2x squared equals 8. And we're trying to isolate x, so let's divide 2 to both sides. And that's going to give us x squared equals 8 divided by 2 is 4. And then to get rid of the square, we need to take the square root of both sides. So the square and the square root will cancel out. X equals, and whenever you take the square root of both sides, a plus or minus is always going to appear on the other side of the equation. So it's plus or minus the square root of 4. And as we know, the square root of 4 is 2, so plus or minus 2. So since our answer is a whole number, let me show you how to check your work. Let's check when x equals negative 2. And you want to use the original equation, 2x squared minus 8 equals 0. So when you plug it in, it's 2 times negative 2 squared minus 8 equals 0, which is 2 times negative 2 squared is 4 minus 8, and it's supposed to equal 0. 2 times 4 is 8, and 8 minus 8 equals 0, which means that negative 2 is a solution. Now let's check positive 2. So I'm just going to fast forward the clip. So we fast forwarded the clip, and now we're plugging in positive 2. So when x equals 2, we'll have 2x squared minus 8 equals 0. That's 2 times 2 squared minus 8 equals 0. 2 squared is 4. And 2 times 4 is 8. 8 minus 8 is 0, so 0 equals 0. And it checks. Let's move on. When you try A, notice how we have 3x squared, 6, and 33. Let's go ahead and simplify this equation so that our numbers are easier to work with. I am going to divide 3 to each term, and that's going to give me x squared. 6 divided by 3 is 2. 33 divided by 3 is 11. Now I want to subtract 2 to both sides. That's going to give me x squared equals 11 minus 2. 11 minus 2 is 9. And to get rid of the square, we want to square root both sides. x equals plus or minus the square root of 9. And the square root of 9 is 3. So x equals plus or minus 3. Let's go ahead and check our work. So check when x equals negative 3. We have 3x squared plus 6 equals 33. Plug in the negative 3. 3 times negative 3 squared plus 6 equals 33. Negative 3 squared is 9 plus 6 equals 33. And 3 times 9 is 27 plus 6 equals 33. When you combine 27 and 6, you get 33, which equals 33. So x equals negative 3 is a solution. Let's fast forward the clip. This time we're going to check x equals 3. Okay, now we're checking x equals 3 and we're plugging it into our equation. Now we're checking x equals 3 and we're plugging it into our equation. So that's 3 times 3 squared plus 6 equals 33. 3 squared is 9. 3 times 9 is 27. And 27 plus 6 is 33. So x equals 3 checks. Now we're on problem B, and unfortunately we can't make this problem any easier because there is no number that goes into 5, 9, and 2. So that said, let's go ahead and just solve this directly. We're going to start off by adding 9 to both sides. Now we have 5x squared is equal to 2 plus 9 is 11. Next, we're going to divide 5 to both sides. X squared equals 11 over 5. Now we need to get rid of the square, so let's take the square root of both sides. X equals plus or minus the square root of 11 over the square root of 5. In math, we cannot have a radical in the denominator. So we have to rewrite our answer so that we can get rid of the radical. To do that, we use this process called rationalizing the denominator. So that's when you take the fraction and you just multiply it by whatever's in the denominator. And what's in the denominator is the radical 5. And then at this step, you just multiply straight across. So x equals plus or minus the square root of 11 times the square root of 5 is the square root of 55. And the square root of 5 times the square root of 5 is the square root of 25. The square root of 55 divided by the square root of 25, which is just 5. And that's our answer. Don't make the mistake of reducing the 55 and 5. They're not like terms. The square root of 55 is not a whole number. So the square root of 55 over 5 isn't the square root of 11. Don't make that mistake. Don't cross them out. Leave them as is. Let's move on. So notice how in part A, the equation is in vertex form. And because it's in vertex form, we can go ahead and use the square roots method to solve this problem. If we look at the left-hand side of the equation, we need to get rid of the square. So we're just going to take the square root of both sides. Square and the radical are going to cancel out. And it's going to leave us with x plus 5 is equal to plus or minus the square root of 36. Which is the same thing as x plus 5 is equal to plus or minus the square root of 36 is 6. Now we want to isolate x, so let's subtract 5 to both sides. X will equal negative 5 plus or minus 6. So we're actually going to have two solutions. we'll have x equals -5 plus 6 and x equals -5 minus 6. So -5 plus 6 is +1, and -5 minus 6 is -11. So class, our two solutions are x equals 1 and x equals -11. Let me show you how to check your work. So let's go ahead and check x equals 1. And remember, we want to take the 1 and plug it into our original equation. The original equation was x plus 5 squared is equal to 36. So that's 1 plus 5 squared, and it's supposed to equal 36. 1 plus 5 is 6, and 6 squared is 36. 36 equals 36. So it does check. X equals 1 is a solution. Okay, now let me show you how to check x equals -11. When x equals -11, we have x plus 5 squared is equal to 36. That's -11 plus 5 squared is equal to 36. -11 plus 5 is -6. And -6 squared is 36. And 36 equals 36. So it does check. Make sure you check your work. Let's move on to problem B. So I'm just going to fast forward the clip. This is starting to look messy. I'm just going to clear the screen. Now that I've cleared the screen, let's go ahead and solve this problem. Notice how the equation is in vertex form. And because it's in vertex form, we're going to use the square roots method to solve this problem. So step number 1 is isolate the parentheses. Get rid of the 3. Get rid of the scale factor. Divide 3 to both sides. Now we have x minus 5 squared is equal to 18 divided by 3 is 6. Step number 2, get rid of the exponent. Take the square root of both sides. The square root and the radical are going to cancel each other out. So now we have x minus 5 is equal to plus or minus the square root of 6. Class, we can't take the square root of 6. We can't simplify the square root of 6 because the factors of 6 are 3 and 2. So you're going to leave the square root of 6 as is. We still need to isolate x, so let's add 5 to both sides. X equals 5 plus or minus the square root of 6. And this is our answer. So if you want, you can split them apart. It's x equals 5 plus radical 6, and x equals 5 minus radical 6. Now, if you have a scientific calculator or a regular calculator, you can type these values into your calculator to see what they actually are. So 5 plus radical 6, if you type that into your calculator, you get approximately 7.449. So if you type in 5 minus radical 6, that's approximately 2.551. Let's do the U-try, problem A. We have 4 times x plus 10 squared equals 24. So step number 1, get rid of the scale factor, get rid of A, by dividing 4 to both sides. So now we have x plus 2 squared is equal to 24 divided by 4 is 6. Step number 2, get rid of the radical, square root both sides, and that's going to give us x plus 10 is equal to plus or minus the square root of 6. Remember, when you take the square root of both sides, a plus or minus appears on the other side of the equation. So now we want to subtract 10 to both sides, and we get x equals negative 10 plus or minus 6. Don't combine negative 10 with 6 because they're not like terms. That 6 is under a radical. So class, our two solutions are negative 10 plus radical 6 and x equals negative 10 minus radical 6. Let's do part B. We have x minus 9 squared equals 64. You start off by, since there's no a value, let's go ahead and take the square root of both sides, which will leave us with x minus 9 is equal to plus or minus the square root of 64, which is x minus 9 is equal to plus or minus the square root of 64 is 8. Take it a step further, add 9 to both sides, and that's going to give us 9 plus or minus 8. So x equals 9 plus 8, and x will equal 9 minus 8. 9 plus 8 is 17, and 9 minus 8 is 1. And those are our solutions. X equals 17, and x equals 1. Okay, class, we have one more problem. A person standing on a second floor balcony drops keys to a friend standing below the balcony. The keys are dropped from a height of 10 feet. The height in feet of the keys as they fall is given by the function h of t equals negative 16t squared plus 10, where t is the time in seconds since the keys were dropped. The friend catches the keys at a height of 4 feet. Find the elapsed time before the keys are caught. We know that the equation is h of t is equal to negative 16t squared plus 10. This is going to represent how far the keys are away from the ground. So let's draw a picture. So we have this person who's at a balcony, and this person drops the keys to his friend, and the friend catches it at 4 feet. So that dot's going to represent our keys. So since the friend catches it, the distance between the ground to the keys as of right now is 4 feet. And we want to figure out how long it took for the keys to be caught. So let's go to our equation. Our terminal height is 4. This is going to be our h value. Let's plug in 4 to h of t. So that's 4 is equal to negative 16t squared plus 10. And from here, solve. Subtract 10 to both sides. 4 minus 10 is negative 6, which equals negative 16t squared. Divide both sides by negative 16. These are going to cancel out. Negative 6 divided by negative 16 is positive 6 over 16, which equals t squared. So at this point, I can reduce the 6 over 16, or I can just take the square root of both sides. And I'm going to take the square root of both sides because if you look at the denominator, notice how it's a perfect square. So t is equal to plus or minus the square root of 6 over the square root of 16. So t equals plus or minus the square root of 6, and the square root of 16 is 4. T equals plus or minus the square root of 6 over 4. So what exactly is the square root of 6 over 4? If I ask you for the time, it wouldn't make sense to say, oh, the time is the square root of 6 over 4 because no one will understand you. The square root of 6 over 4 is, so t is approximately plus or minus point, if you type that into your calculator, it's 0.612. So we're referring to time, class, so time should be positive. And because this is a word problem, let's write our answer in a sentence. It will take 0.612 seconds for the keys to be caught. So that concludes our lesson for today. If you like this video, go ahead and give it a thumbs up, and don't forget to subscribe.